Hey there, and welcome. Let's dive straight into this explainer and learn how to completely transform ourselves into scientists. How? By mastering an absolute superpower, designing our own experiments. Whether you realize it or not, the world is just full of incredible mysteries waiting to be solved. Have you ever wondered why your phone battery mysteriously drains way faster in the cold winter air? Or think about this: how does a tiny, dense lump of dough transform into a massive, fluffy loaf of bread in the oven? Well, today, we're going to learn the exact comprehensive framework used by professionals to crack those everyday codes and unlock the secrets of the universe. So have you ever looked at the world around you and just wondered how scientists actually uncover the truth about how things work? Like, how do researchers know exactly what nutrients make a seedling sprout up from the soil so aggressively? Or why a block of ice melts at one highly specific temperature but stays perfectly solid at another? I mean, they don't just throw things at the wall and guess, right? Instead, they rely on a highly structured, almost foolproof system to navigate from sheer curiosity to absolute certainty. And really, it's not about magic or random luck or just having a good gut feeling. It's about relying on a solid sequential methodology to actually test ideas against reality. A scientific investigation is basically just a step-by-step process used to answer questions and solve complex problems by meticulously gathering evidence. Think of it as a logical pathway, one specifically designed to completely remove human bias and reveal the unvarnished truth. Here's our roadmap for today's lesson. We'll start with the steps of discovery, learn how to write an experiment recipe, master our variables, put it all into practice with a paper towel test, and finally, draw our conclusions. All right, let's jump into section 1, the steps of discovery. This structured approach is literally the foundation of every great scientific breakthrough. Let's walk through the 5 essential stages that make up our scientific recipe. This keeps everything incredibly organized. First, you always start with your aim or problem. That's identifying the exact question you want to answer. Next up, you gather your materials and equipment, meaning you collect every single physical tool you're going to need. Then comes the method or procedures. This is your detailed step-by-step action plan. After you execute that plan, you record your results, meticulously documenting the data. And finally, you arrive at your conclusions, where you analyze what that data actually means. Honestly, every single legitimate scientific paper you will ever read follows this exact backbone. Moving right along to section 2, the experiment recipe. Setting up for success here is absolutely crucial. If you get this setup right, the rest of your investigation just flows naturally. So your aim is the beating heart of your investigation. A bad aim is something super vague like, do plants like water? That doesn't really tell us much, does it? A good, highly measurable aim is, does adding 50 milliliters of water daily increase a tomato plant's height faster than 10 milliliters? See the difference there? Then you've got your materials. These are the adequate, safe tools you need to actually get the job done. And hey, safety here is completely non-negotiable. You absolutely have to ensure you have goggles, gloves, or whatever protective gear is required before you even touch a beaker. Now, your method is literally the recipe for your experiment. It needs to be so clear and sequential that anyone else in the world could easily repeat it. Think of it kind of like baking a cake. If you just hand someone a recipe that only says, bake it, your friend might put it in a microwave for an hour, and, well, we all know how tragically that ends. Your method must outline exactly what you will do in the precise order it needs to be done. Once you actually run the experiment, you record your results as data. This can be observations of what you saw, specific measurements, or highly organized tables and graphs. Think of your results as a collection of individual puzzle pieces. Your conclusion, then, is where those puzzle pieces finally click together to form that brilliant light bulb moment of understanding. Your conclusion must always be based strictly on the evidence you collected, stating loud and clear whether your data supports or rejects what you originally thought would happen. Okay, section 3, mastering your variables. Let's dive into the secret sauce of any real experiment. But wait, before you even test your variables, you've got to form a hypothesis. Now, a hypothesis is never just a wild or random guess in the dark. No way. It's a logical deduction based on things you already know to be true, your prior knowledge. For example, knowing that plants use photosynthesis, you might hypothesize that plants placed in a sunny location will grow taller than plants placed in a dark closet. It's an incredibly informed prediction that beautifully sets up your entire test.
Now, we get to the core mechanics. The independent variable is the one specific thing,
You, the scientist, purposefully change to see what happens. Going back to our plant example, the independent variable would be the amount of sunlight you provide. It's the deliberate action you are taking to spark a reaction. A really great trick to remember this, just remember that I control the independent variable. On the flip side, the dependent variable is exactly what you are measuring to see the result of that change. In our sunny plant experiment, the dependent variable is the plant's growth. You'd use things like a magnifying glass, a ruler, maybe a stopwatch. These are the classic instruments you use to measure your dependent variable. It literally depends on the changes you made to the independent variable. Think of it this way. The independent variable is the cause that you are directly manipulating, like turning a dial. The dependent variable is the effect reacting to that change. If you can firmly lock this fundamental cause and effect relationship into your mind, you will be able to design a robust experiment to test virtually anything in the natural world. But wait a second. How do we actually know the sunlight was the only thing making the plant grow taller? To ensure your test is totally fair and accurate, you must use controlled variables. Everything besides the sunlight must be completely identical. You need to use the exact same pot size, the identical amount of water, and the same brand of soil for both plants. Without strict controlled variables, your resulting data is honestly completely meaningless because you won't know what actually caused the change. Section 4, the paper towel test. Time to put on our lab coats and see where all this theory becomes practice. Our aim here is very clear and measurable. We want to find out, does brand A paper towel absorb more water than brand B? Come on, we've all seen those exaggerated late-night infomercials where someone hopelessly spills a giant gallon of milk across their kitchen island, right? Followed by some bold claim that their specific towel is the absolute most absorbent in the world. Well, we are going to put that to the test. Our logical hypothesis is, brand A will absorb more water than brand B. Now, to make this a fair test, we have to be meticulous about our controlled variables. We must use identical towel sizes, exact 10 milliliter measurements of water in identical beakers, and precise timing with a stopwatch. Think about it. If you submerged brand A for 5 seconds, but you accidentally let brand B soak for a full minute, your data is completely corrupted. Timing is everything. These controlled variables guarantee that the only thing affecting the outcome is the brand of the towel itself. Our method is a highly specific, repeatable recipe. Step 1, we precisely pour 10 milliliters of water into a beaker. Step 2, we submerge our independent variable, the specific towel brand, for exactly 5 seconds. Step 3, we carefully remove it and squeeze the excess liquid into a separate container for 10 seconds. Finally, step 4, we measure the remaining liquid in the original container. The dependent variable here is the amount of water absorbed, which we figure out by seeing exactly how much water is missing from the original 10 milliliters. Here is a crucial pro tip. In science, doing something just once is never enough. You must repeat this exact process a total of 3 times per brand. Why? Well, because you might have grabbed a weird defective paper towel from the roll by accident. Taking an average of 3 distinct trials smooths out those anomalies. By conducting multiple tests, we ensure our data is bulletproof, reliable, and truly representative of how the brand actually performs. Finally, Section 5, drawing your conclusion. We've done the heavy lifting, now let's analyze those numbers. After diligently gathering our data across all 3 trials, our results are incredibly telling. The data clearly shows brand A reaching all the way up to the 8 milliliter mark on average, leaving brand B far behind at just 5 milliliters. Because we recorded these as specific, numerical measurements, rather than just, guessing which towel felt heavier in our hands, we can definitively and scientifically compare their performance. So what's the verdict? Our evidence-based conclusion flawlessly supports our initial hypothesis, proving that brand A absolutely gets the blue ribbon today. The data is undeniable, the test was exceptionally fair thanks to our controlled variables, and we have successfully answered our original aim using the rigorous step-by-step methods of a true scientific investigation. Now that you possess the ultimate superpower of the scientific method, look around your world. Think about the massive claims you hear every single day in flashy advertisements, on the nightly news, or even just from your friends. How many of those are just untested hypotheses waiting for someone exactly like you to step up and demand the data? Keep observing your world closely, demand rigorous evidence, and I'll see you in the next explainer.